Hi folks, here is a couple of examples from our latest section here where I can identify and apply similar polygons. Here are a couple of polygons. The question is, are they similar? If they are, let's write a similarity statement. So we need to find the corresponding sides. The angles all appear to be congruent, which is what we want. So we look at the congruent symbols, they're all corresponding or all matching. But let's take a look at the corresponding sides. So this side is 6, it corresponds with that 6. So I'm going to write a fraction. It's going to be 6 over 6, a ratio comparing one to the other. I'm going to compare the larger to the smaller. Here we have 12 over 6. I already see a problem. We have 24 over 16, and we have 24 over 14. Well, if these were similar, each of these fractions would reduce to be the same fraction, but that's not going to happen here. That's 1, that's 2, that's, I don't know, but that's all. These are all different. So they don't equal each other. So no, these are not similar, right? So let's go over here and look at this one. The angles are congruent. We've got the 3 marks, we've got the 2 marks, the 1 mark. Now these are turned around, they're not oriented the same way. But let's check the angle, let's check the sides. Now we got to be careful and see if we got to find corresponding sides. So let's look at that 8. That 8 goes with that 10. It's between the 1 and 2 marked angle. Between the 1 and 2 marked angle is 10. So that's the fraction we need. Then we've got the 16, and that's between 1 and 3, and that's the 20. And then the 12 is between the 3 and the 2, so between the 3 and the 2 is 15. The question is, do those reduce to be the same thing? Well, that's 4/5. I can divide by 4 and divide by 4. That gives me 4/5. So far, so good. I'll divide by 3, and that gives me 4/5. So yes, these are similar. So now we can write a similarity statement. So here we can say a triangle ABC is similar to triangle. Now we want to make sure that we do this in the right order. So since A was the one with the 2 marks, we have to start with the one with the 2 marks, D. And then we went to B with 3 marks. Here it's E, and lastly F. So there's the similarity statement for that particular one. The next example, the question is, what is the value of X? We're saying that the 2 shapes are similar. So that means all the angles are congruent and the sides have to be similar. So I'm going to go ahead and compare this X with its corresponding side right here. So I'm going to write X over 7.5, and then I'm going to find another set of corresponding sides that I know the 2 lengths for. And that's right over here. This length is 6, and this length is 9. So I'm going to put 6 over 9. Now it's important that we use the smaller to the larger, so over here the smaller to the larger. So 6 over 9 is here, and then we have to cross multiply. So 9 times x is 9x. 6 times 7.5, not really sure. Let's find out. 6 times 7.5 is 45. And remember, we set those cross products equal to each other and solve for x. Divide by 9, x is 5. There's that problem. Last problem has to do with the Golden Gate Bridge. How long is it between the supports? So again, we're looking for, this is a map, like a scale. There's the scale. So I actually like to use the scale as a ratio. So 1 centimeter over 200 meters equals, now this fraction over here is going to have centimeters over meters in that order. So if we look up here, we're given the short centimeter number, and this is my unknown value. So I can cross multiply this. So x times 1 is x, and 200 times 6.4 will be my answer. 200 times 6.4 is, you can't see it, is 1280. So 1,280, and the unit is in meters. So the Golden Gate Bridge between the supports is 1,280 meters.